Hi lovers of numbers and music. This is the third in a series of videos about number partitions and music. In the two previous videos I looked at how to generate number partitions using the Bach library in Max, and then how to generate all unique permutations of a partition. In this video I'll look at some of the properties that a partition has and how to visualize them using coll and jit.cellblock. In this patch I have a place that I can give a number, assign a number for a partition to be made. If we take a simple number like 4, this patch partitions the number. We'll see there are 5 different partitions that are possible of the number 4, and it displays them in a jit.cellblock. It also displays in the next window, which is another kind of parallel jit.cellblock, it displays some of the properties that these partitions have. We've looked first of all at the property that's called members. This has a list of the different numerical members that a particular partition of the number 4 has. So this has the members 3 and 1, this one has the numbers 2 and 1, and so on. If we take a slightly more complex, or slightly larger partition, for example 8, of which it turns out there are 22 unique partitions, we can see that, for example, in partition number 11, this is the index here along the left hand side, the index number for that particular partition when the partition is generated in ascending order. So the 11th partition has the numbers 3, 2 and 1, 3, 2 and 1, and then the partition 14 has 4, 2 and 1 here. So here are given the members for the various partitions, and to the left of the members are the number of occurrences of those particular numbers. So in the case of this 14th partition 4211, there's one occurrence of the number 4, one occurrence of the number 2, and 2 occurrences of the number 1. So this occurrences follows the same order as the members. And then it gives us the number of members altogether, which is just the counting the number of members in this box. So there are 3 different members. And it gives then the length of the partition, which is the length of the partition is 4 because there are 4 items in the partition. So those are some of the most basic properties before we start delving into what more complex properties a partition has. These are the essential ones. What this patch also allows me to do, apart from look at the properties of a particular partition, is that when I click on a certain partition, let's say if I click on number 11, then in this window on the right hand side it gives me all the unique permutations of that partition, which in this case are 12 in number. So this gives all the different possible orderings, unique orderings of this 3221 partition. We'll go and look later at the properties that the permutations can have, because they could be interesting. For example, a permutation might be, for example, a palindrome, or it might have certain particular numbers in series and so on. So So permutations also have properties, but to start with, we're looking at the properties of the partition itself. I'll show very briefly how the partition information is gathered inside the cell block. In actual fact, first of all, it's gathered into a coll, the max data object coll. We look here how this happens. The coll is here. The coll is called partitions. We open it up. We can see that the index is down the left hand side, and that's what we access the coll with. Then each of the partitions is given. Most of the partitions are in inverted commas, double quotes. And the reason for that is that this is the only way we can put a list of numbers into a coll without the list falling apart. So we'll look at how that's done. But once it's in the coll, then we can connect the jit.cellblock to that particular coll using a referral operation. I'll show that just in a minute. But basically, the way these partitions are made and then get into the coll is that first of all, they're made using bar partition, which we looked at previously. They're iterated. Bar flat takes away the layer of brackets around the partitions, and then they are indexed by the counter. They're converted to a symbol. That's in order to put the double quotes around them, the quotation marks around them, and they're packed. The symbol and the index are packed, and they're put into the coll. To get them out of the coll again, we access them with the index. We last looked at the index 11. Then the coll will send them through root, which takes away basically the word symbol from the beginning, because when they come out of the partition, because they're preceded by the word symbol, this removes it. Then they're converted from the symbol into a standard ZL type of list, and then they go out of the partition. So this is how the partitions get into the coll, and exactly the same procedure is used for putting the properties into a coll, except the properties will have several sets of quotation marks around these different strings. But otherwise it's an identical method. So let's have a look at how we refer the jit.cellblock to the coll. It happens here. Here it says load message, refer partitions. So this at startup, this message is sent into the cell block, and it refers this cell block to the coll partitions. This little mechanism here is just to allow us to highlight to give a background color to the particular partition that we've selected. So when I select this one, I get a background color, or this one, I get a background color. Same thing works here, just to indicate which one is selected. Once we have the permutations of the partitions, we can send them, for example, to make a particular scale, for example, or to make a chord or a rhythm. For example, this 13211 will give us the little figure here, this little figure that is semitone, minor third, semitone, whole tone, semitone. Just so that these are semitone values, 13211. So that's how we get the the partitions created and put into the cell block, and the properties displayed. And finally, we can start to look at this idea of searching for particular properties within. So we search through this array for certain properties. We can search, for example, for all the partitions of the number 8 that contain the numbers 2 and 3. And it turns out that there are 3 of them: 5, 11 and 17. So let's check that that's true. 5 contains the numbers 2 and 3. 11, numbers 2 and 3. And 17, the numbers 2 and 3. But other partitions of this number don't contain those 2 members. Or we can go and search for a partition of a certain length. Say we search for the partitions of length 5 of the number 8. Then we get 15, 17 and 18. And it turns out that 17, the partition number 17, which is this one, is the only one which is in both of these lists. So when we do an intersection between these lists, we find that 17 is of length 5 and contains the numbers 2 and 3. 2 and 3 and length 5 here. So this is an example of a simple search on the basis of the partition, various partitions that we can get out of a number, and we can start to look at how to do that in Bach in the next video. So bye for now.